Thevenin's theorem was developed by Commandant Leon Charles Thevenin in 1883 for use in DC circuit analysis. It is one of the most useful analysis methods in DC circuit design, as it permits the reduction of complex electrical networks into a simpler form for more straightforward analysis and design. In general, the theorem can be used to analyze networks with sources that are not in series or parallel, to reduce the number of components required to establish the same characteristics at the output terminals, and to investigate the effect of changing a particular component on the behavior of a network without having to analyze the entire network after each change. To demonstrate the power of this theorem, consider this fairly complex network. To form a Thevenin equivalent circuit for this example, first remove that portion of the network where the Thevenin equivalent circuit is found. This requires that the variable load resistor RL be temporarily removed from the network. Then mark the terminals of the remaining two-terminal network. The importance of this step will become obvious as we progress through some complex networks. Then calculate RTH by first setting all sources to 0. Voltage sources are replaced by short circuits and current sources by open circuits. And then finding the resultant resistance between the two marked terminals. If the internal resistance of the voltage and or current sources is included in the original network, it must remain when we set the sources to 0. Then calculate ETH by first returning all sources to their original position and finding the open circuit voltage between the marked terminals. This step is invariably the one that causes most confusion and errors. In all cases, keep in mind that it is the open circuit potential between the two terminals marked in step 2. Finally, draw the Thevenin equivalent circuit with the portion of the circuit previously removed replaced between the terminals of the equivalent circuit. This step is indicated by the placement of the resistor RL between the terminals of the Thevenin equivalent circuit. Thus, you can simplify the complex circuit into one containing only a voltage source and a resistor. This allows for easy analysis of electric circuits, where one part of the circuit may remain constant while the rest of the circuit changes.